All right, for the second page of 2.1 notes, we are going to actually do some of the transformations, okay? So this wants us to describe the transformation to this parent function, then graph the function, and then state the domain and range. So I look at the equation. My parent function is just the x squared, so something else is added in here. Remember, if it's just a number tacked on to the beginning or end, that is shifting it up or down. In this case, it's a positive 4, so it's going up 4. And then we graph it. So instead of starting at 0, 0, I said it's going up 4. And be careful of your units here. And I told you to memorize those points. 1, 1, 2, 4, 3, 9. From my vertex or my new starting point, I plot those. I don't start at the origin. I start at this point, and I go right 1, up 1. And again, pay attention to your units. And I also go left 1, up 1. I go right 2, up 4. Left 2, up 4. And again, my over 3, up 9 is not going to fit. So I make my U. Make sure your graph is a U. It is not a sharp point. Okay, absolute value had a sharp point. And quadratics are a U shape. It's just a curve, no sharp points. Okay, so we graphed it, and then it wants us to state the domain and range. So the domain are all the possible x values. So to the left, even though it's going left slowly, it is forever going left. So it goes all the way to negative infinity, and then on the right, it's going right slowly, but it's still going always to the right, so it's to positive infinity. So it's all real numbers. And if you're tired of writing that out, that is the symbol for all real numbers. It's just an R, but it has 2 bars in the front instead of just the 1. Okay, and then I want the actual range. That's the possible y values. It doesn't go down forever. Okay, there's no y included in my graph until I'm up at 4. So y is greater than or equal to 4. And then it goes up forever. So that's why it's greater than there. All right. Number 2, we want to state what's going on. Well, there's something grouped with my x that moves us left or right. And instead of going left 1, we do the opposite thing. So remember, h here is just a positive 1. So we're going to go right 1. That minus 3 tacked onto the end means we go down 3. So to graph it, I start at 0, 0, and I go right 1, down 3, but we've got to pay attention to units. It puts me right in the middle, right there. And then these points are what I use to graph. From that start point, I'm going to go right 1, up 1. And then from that start point, I go right 2, up 4. From that start point, I go right 3, up 9. And we also go to the left side, so it's mirrored. And then we connect, making sure that's a curve. And then we state our domain and range. Well, my domain is all real numbers. And my range is y is greater than or equal to a negative 3. Okay, so for number 3, we state what's happening. That negative in front means there's a reflection, so it's reflected. Then if something is grouped with x that moves us left or right, in this case it's going left 9. And there's no other changes to that x squared. So I'm just going to go from the start, left 9. Again, watch units. This one's counting by 3s instead of 2s. And you use these same points, but now I got to do something different to it. 1, 1, 2, 4, 3, 9. Because of this negative out front, I've got to do something to these points. So that way I plot it correctly from this start point. Now, if this was just a number, it'd be the same as it is now. So we're going to, instead of now, sorry if I can talk, we know it reflected, but now I want you to think of this as a number. This is negative 1, right? So we're going to take that negative 1 and we're going to multiply all of these y values. So I'm going to take them times a negative 1. So if I multiply a negative 1 times times 1 times negative 1, I get negative 1. 4 times negative 1, I get negative 4. 9 times negative 1, I get negative 9. So my points changed. Instead of 1, 1, I'm actually going to plot 1, negative 1, and 2, negative 4, and 3, negative 9. We do the same thing if there's even just a number in front. Like if this was a 2, I would multiply all the y values by 2. It's always the y values. Leave x 1, 2, 3. Okay? So from the start point, I'm going to plot these points that I made. So I go right 1 up, or I'm sorry, right 1 down 1. And again, remember your units are counting by 3s, so it's a little different. From my start point, I'm going to go right 2 down 4. And again, left 2 down 4. And then from my start point, I go left 3 down 9. And I go right 3 and left 3. There we go. And then we connect our dots. It's going to look something like that. So that negative reflected us down. This helped us plot them in the proper place. Now, my domain is still the same, all real numbers. My range, however, y is not greater than, because it doesn't go up. It's going down. So it's going to be y is less than or equal to, and that's when y is 0, because there was no shifting up or down. So it's y is less than or equal to 0. Now if we come down here to number 4, this one's just going to go down 7. So I go ahead and plot that point. I use these points that we memorized, 1, 1, 2, 4, 3, 9, because there's nothing multiplying here. So from here, I'm going to go right 1, up 1, and left 1, up 1. Right 2, up 4, left 2, up 4. And I'm going to go right 3, up 9, and then I'm just going to go ahead and draw my graph. I do want you showing the points, at least this many points on both sides, even once you mirror it. So going left and right. I want this many points shown on your graph, not just your curve. They need to go through exact points. All right, so domain, all real numbers, range, y is greater than or equal to negative 7. All right, so this one now has a 1/3 in front. So this is a vertical shrink, and it's going down 6. So I go ahead and plot the down 6 as my starting or my vertex. And just for space, I'm going to use part of this space down here. This is for number 5. I'm going to write those points. 1, 1, 2, 4, 3, 9. This time I'm multiplying by 1/3. So I take all these y values and I multiply it by 1/3. And I write them as decimals because I find decimals easier to plot. So 1 times 1/3 is now 0.3 repeating, so 0.3 is fine. 4 times 1/3 is now 1.3. 9 times 1/3 becomes 3. Now, because I'm getting so flat, I could probably keep going and do 4. 4 squared is 16. Okay, 16 and 1/3 is 5.3. I could probably even keep going past that, but I'm going to go ahead and stop. I'll get enough for my graph. So, from my start point, I go right 1, up 1/3. It's really hard to do there. From your start point, you go right 2, up 1.3. Go right 3, up 3. Oh, I did not count correctly here. Ignore those points. I'm sorry. I got my units wrong here. Forgot it's counting by 2s. Okay, pay attention to units. I need to as well. So then it puts it here, that 3, 3. And then go right 4, up 5.3. So right 4, up 5.3. And we go ahead and make our curve. We know it keeps going past those. Okay, so domain, all real numbers, range, y is greater than or equal to negative 6. Okay, so for this one, I now have a vertical stretch. It's going right 2, and up 1. So I go ahead and do the right. Now this one's counting by 4s. So right 2, up 1 is like right there. That's my vertex or my starting point. And my points here for 6, 1, 1, 2, 4, 3, 9. I take that number in front and I multiply the y value. So I'm taking this one times 3. 1 times 3 is 3. 4 times 3 is 12. 9 times 3 is 27. Whoa, I wrote 29. I said 27. Okay. Whew. Now, if I plot from my start point, I go right 1, up 3. I go right 2, up 12. Obviously, up 27 is not going to fit. So, whoops, I went too far. It goes here, not there. And then I connect my points. Sorry about that. So my domain is all real numbers. Range is y is greater than or equal to 1. So it's easy to find those incorrect numbers if it's not going to make a pretty U. So, because it should be smooth. And you can always check them on your graphing calculator. I'll show you how in just 1 minute. So consider this function. We just want to describe what happens and identify the vertex. And we've been really identifying the vertex all along. We just haven't been writing down what that point actually is. But you've been drawing your vertex every time. So if I start at the negative, I know it's going to reflect. I know it has a vertical stretch because that 10 is better or is bigger than 1. So it has a vertical stretch. It's going right 5. And that positive 7 is going to make it go up 7. So there's 4 different things this graph is doing. So its vertex, well, it goes right 5, up 7, which means x is a positive 5 and y is a positive 7. This going right 2, up 1, it meant our vertex was at 2, 1. Okay, we've been finding the vertex all along. It's that starting point. Now, on your graphing calculator, you can just plug these in. The squared is just a button. Do put in parentheses, and you can double check your graphs. I'll show you more on that when we get to the next, when we get to 2.2.